Hello dear students, thanks to for watching my lecture. Today I am talking about deliver my lecture on physics first paper, chapter 5, work, energy and power. This is really very important chapter in our physics. In my previous lecture I give some example of the mathematical problems related to the constant force, work done by the constant force. Now today I also give some special example on constant force. So then we move to find out the work done in case of the variable codes. My dear students, if you do not see my previous lectures, then please go to the description section, and here we give some links of the lecture. Okay, you easily find out. Okay, my dear student, today I try to give you another special problems that will really very helpful for your any kind of the exam. My dear students, suppose in case of the constant force, now I am trying to draw a special diagram. Suppose this is the spatial diagram. Here has an object. Suppose this is the object. This is the object. Okay, this is the object. Suppose we apply the force on the object this direction. This is the direction of the applied force. Okay, the mass of the bulb, you just see this is a pendulum. The mass of the bulb is m and length is L is equal to suppose 2 meter. Okay, my dear students, because of applying force this direction, the mass of the bulb is 2 kg, suppose 2 kg. If the bulbs goes from, suppose the force is 100 Newton, if the force go from point A, suppose this is the point A and mass is 2 kg. If the bulb goes from point A to B, suppose because of applying force, this bulb go from point A to B. When the bulb comes here make an angle. Okay, how much angle here make? Suppose the angle is 30 degree. Angle is 30 degree. Now our duty is to find out the work done. Now our duty is to find out the work done because of the applied force. Okay, my dear student, as the direction of force, this direction, so as this is the direction of the force, before find out the work, we know the equation is F is cos theta. Okay, F means force, S means displacement, and theta means angle between the applied force and the displacement. As we apply the force this direction, so our duty is to find out the displacement this direction. Okay, as this is the L, this is the L, this is the L, so our duty is to find out the displacement this direction. Okay, how we can find this? Suppose this can be find out very easily if you have knowledge. Suppose this is a perpendicular on OA. This is D. BD perpendicular on OA. Okay. Now we can divide this amount of force into two components. One is horizontal component, another is vertical component. Okay. Now you just try to understand actually what is happened here. Suppose this is a direction and this is, if this angle theta, and this is also theta. Okay, now we can divide L into two perpendicular component. One is this component, L cos theta. L cos theta will be exactly this, L cos theta. This is OD L cos theta, and another is L sin theta. Okay, this is the L sin theta. This is the value of the L sin theta. Actually, this will be the displacement of the object. Suppose if these objects do not go from point A to B, if this object comes here, that means this is the length, effective length, and this will be the displacement. If this body comes here, then try to imagine what is actually happen. Then this displacement will be less. Why? Because of the angle. Because of the angle. As now the value of theta is 30 degree. When this body comes here, this angle will be decreased. Because of that reason, the value of L sin theta will be decreased right now. So, my dear student, I think that you can clearly understand, as this is the direction of the force, this is the direction and force. Now we can take displacement this direction. Okay, when this body comes from A to B, or the body go from A to B, then the displacement here occur along the direction of the force is L sin theta. So we can put our equation, then we get the work. F means F S means displacement. How much displacement occur here? L sin theta. So we can write L sin theta into cos 0 degree. Why we put cos 0 degree? Because this theta denoted by suppose this is theta, this is the theta prime, or we can write here cos 0 degree, because F is cos 0 degree. Why we write 0 degree here? Because this is direction of force and we take displacement this direction. Because of that reason we write here. If the value of force is 100 Newton and value of L is 2 meter, suppose value of L 2 meter, sin 30 degree, we get the work. Okay, my dear student, this is also a pretty example of work done by constant force. Now today I am trying to discuss about the work done by the variable force, work done in case of the variable force. My dear student, I think that all of you clearly understand this section very clearly. Okay, now before describing the work done by the variable force, now our duty is to find out these types of the work done by integration process. We know integration is a very special method that we can use to find out the total things from the very small part. Okay, now we try to discuss work done by variable force. Work done by variable force. Work done by variable force. This is really very important part in our physics. Okay, suppose this is x-axis and this is y-axis. We put displacement x-axis, displacement this direction, and force will be this direction. Okay, suppose this is the graph force versus displacement. When the displacement here, suppose when the displacement is x1, we measure displacement from the origin. This is the 0, 0. When displacement x1, then the force will be F1. My dear student, when displacement here, when displacement x2, then we see the force do not here. Okay. When displacement x1, the force is F1. When displacement x2, then force will be changed here. The force will be F2. Here we can see force versus displacement is a function. Force and displacement is a function. Okay. After putting the value of the displacement, then we get the force. Okay. Suppose we can write this equation by way. F is equal to 2x or F is equal to 4x. If we put the value, suppose we put the value of x in this equation, suppose if the value is 1, then we get the force is 4 into 1, that means 4 Newton. If we put the value of displacement 2, then we get the value of force 4 into 2, that means 8 Newton. Because of that reason, here we can see the relation between the force and displacement is totally different. Okay, this is the independent variable, this is the dependent variable. When the value of x is 1, the force is 4 Newton. When we increase the displacement, then force also changes. Because of that reason, here we can see because of this displacement, in our previous section, suppose if the body here, we learn in our previous section, we learn if we apply force F is equal to 10 Newton, then the body comes here, S is equal to 5 meter. Okay. In this situation, we see this is the magnitude of force. When the body go from A to B, we do not change this force all the time. Suppose the body has taken the time from point A to B, go from A to B 5 seconds. 5 seconds. This 5 seconds, all the 5 second time, we do not change this force. Because of that reason, this force is a constant force, because we do not change the directions and do not change the displacement. Because of that reason, here we can see the force is a constant all the time. When the body go from point A to B, if it need 5 second time, then we do not change the magnitude of the force. All the 5 second time, all the time we applied same amount of force. Because of that reason, we can say this is the constant force. But in case of this function f is equal to 4x, we see here when displacement is 1 meter, then after putting the value of the displacement in this equation of the function, we get the value of force is 4 Newton. Because of that reason, we see because of 1 meter displacement, it is needed 4 Newton of the force on the body. If we need 2 meter displacement, after putting the value of this equation, we get the value of force is 8 Newton. Because of that reason, this is the function of force and displacement is a function. Here we can see the force is a variable. Because of this variable force, how can we measure work? This equation cannot valid for this. Which equation? If we measure the work, Fs is only valid for the constant force. My dear student, always try to keep your mind. If you want to measure the work, then always you have to remember that you have to develop your concept. You must be conscious about the force. You just try to find out the force is constant or variable. If the force is constant, then we use this equation. If force not constrained, then we do not use this equation. Then we have to change this equation. Okay, now my dear student, I am trying to describe these problems very easily so that you can easily understand. Now, as force and displacement is a function, so we just see our diagram. We need to find out the work done between displacement x1 to x2. Because of this displacement, we need force F1 to F2. Okay, F1 to F2. When displacement x1, force is F1 Newton. When displacement, suppose the unit of the displacement is meter and force here Newton. Okay, my dear student, when displacement x1 meter, then we need force F1 Newton. When we change the displacement of the object and we need to displacement x2, how much amount of the force is needed here? F2 Newton. My dear student, try to understand. We know just equation of the measured work only for the constant force, Fs. This is our equation. When we use this equation, if the direction of the force and direction of the displacement is same, that means when the value of theta is 0 degree, theta means the angle between the applied force and the displacement. When the direction of the force and direction of the displacement is same, in this situation we can write this equation. And another concept here, F must be constant. Okay, right now. Now we try to understand, as we know only one equation for measuring work for the constant force. This equation, only we know this equation. My dear student, from where we know this equation? We know this equation as we know force is a vector component and displacement also a vector component. So if we apply the dot product here, then we get this equation. We know dot product is a very special operation from making scalar quantities from the two vector quantities. Okay, F is a force is a vector quantities, S is a displacement also vector quantities. Because of that reason, we apply here dot application so that we can get the scalar quantity, because work is a scalar quantity. As work is a scalar quantity, so we use this dot product. From this equation, we get this equation. My dear student, try to understand. Actually, you just know this equation. Suppose if we use this equation to find out the work done for this area, okay, from displacement x1 to x2, from displacement x1 to x2, we need force F1 to F2. Okay, within this displacement, we need force F1 to F2, and we just measure work. How can we do measure? That is our question, because we know the equation we know equation to measure the work done, W is equal to Fs. This is only for the equation valid for the constant force. My dear student, try to understand. If we take a very slight or very small displacement, suppose this is very small displacement. Okay, this is very small displacement. The displacement will be dx. Okay, and because of this very small displacement, we try to understand how much amount of the force needed here. Suppose F1, the force look like as a constant. Why? When this F1 force look like a constant, if we take the displacement very small, as small we take the displacement, the force looks like as a constant force. Because of this very small amount of displacement, we can take F1 force is a constant. If we move to the next section, suppose again we take a very small amount of displacement, suppose this displacement also dx. Because of this displacement, another constant force F2 also look like a constant. Try to understand actually what is happened here. Because of first displacement dx very small, because of this section we just mark out, because of this very small displacement, because of this very small displacement, the force need this force look like a F1. If we take this very small amount of the displacement, suppose this displacement is second dx, because of this displacement we need a small amount of force. This very small amount of force F2 look like a constant force, another constant force. Okay, if we divide the displacement between x1 to x2 many thin part, same width. Okay, suppose this is suppose this is every part the displacement is equal. Every cross section here we just write here the displacement will be same. Suppose if we zoom this section here, suppose this is the displacement, this is the displacement, this displacement dx, this displacement dx, this displacement dx. Because of first displacement force is F1, because of second displacement force is F2, because of third displacement force is F3. By this way we just divide many part here, many part. Okay, now we know the equation to measure the work done. So suppose for the first displacement dx we need force F1, so work done will be W1. If the second displacement very small, same amount of the second displacement very small amount dx, we need force F2, so work done will W2. For the third displacement very small dx, third displacement, suppose this is the first, this is second and this is third, all the displacement here same. We divide x1 to x2 many small part, many small part, every small part width will be same. Okay, because of this very small amount of the part dx, we need force F1, this is constant, so we can write this equation. This equation is valid only for that condition. The condition is the displacement must be very small amount. If the displacement is very small amount, because of this small amount of the displacement, the applied force look like as a constant force. Because of that reason we write this. Okay, F3 work done is F3. By this way, if we divide x1 to x2 many part, suppose n number, then work done will be n, so applied force n dx. Okay, now our duty is to summation. After summation we get the total work. Suppose the total work will be W is equal to W1 plus W2 W3 plus Wn. After putting the value F1 dx plus F2 dx plus F3 dx Fn dx. This is the equation to find out the work done. Okay, W is equal to F1 dx plus F2 dx plus F3 dx Fn dx. Okay, my dear student, now our duty is to represent this equation by a special notation. We can represent this equation with a special notation. The notation will be look like, okay, as this is the work so this is the total work. So we can write this notation by special notation, okay, summation. As we can see, this is the summation, all the small work, small work, small work, small work. If we summation all the very small work, then we get the total work. Suppose we apply f dx. Our value of n, suppose 1 to n. So we state the value of n 1. Suppose we write here I cap to n. Okay, the value of I will be 1, 2, 3 dot 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 n. When we put the value 1 in this equation, the value of 1 means f1 dx, f1 dx. If we put the value of I 2, that means we put value here 2. If we put value here 2, we get the second part. By this way we get all the part. Now our duty is to write this equation again, okay, as summation of fi dx is a very summation of every or very small part. As we summation very small part, very small displacement, the work will be very small. So we can write this equation by this way. This is the summation. In our integration mathematics, we can replace this summation by this notation for our integration operator. Okay, so we write here f into dx. Okay, f into dx. Now this is the equation to find out the work done. When we see any kind of the variable force and any kind of the displacement, if the displacement is variable, if the force is variable, then we can find out the work with the help of this notation. We just put the value of here as this is the summation. We can also write this equation by this way, f dot dx. After putting the region within x1 and x2, we can find out the work x1 and x2. This is the limit. Within this limit, we find out the total work. Now I just try to give you a very special example, then you clearly understand. Suppose this is the function, displacement and force is a function. Suppose the function is 2x. Okay, function is 2x. Okay, if this is the function, then we know for find out the work done, f dx. Suppose we want to find out the work done within 8 meter to x2 is equal to 2 meter within this limit, or x2 is equal to 4 meter. So if we put the lower limit here and upper limit here, now we put the value of f means 2x, this is 2x dx. Okay, if we put the value 1 lower limit and 2 upper limit, or 4 is a upper limit. As we know here, integration will be with respect to x, so 2 comes out from the integration sign and x dx. Okay, we put value 1 to 4. Now we solve these problems. We know x square divided 2, 1 to 4, 2 comes out, cancel out, 4 square minus 1 square, 16 minus 1, that means 15. Okay, my dear student, I think that all of you clearly understand. So in case of the variable of the force, and if the displacement is a variable, then we can use this equation for measuring work. Now I am trying to give you the real example. How can we do this? Okay, my dear student, in case of the spring, when ideal spring, if we take an ideal spring and extend, then we need force. this force will be variable force here. Okay, suppose in case of the variable force, we take an example 1. Example, in case of ideal spring. Work done by variable force in case of ideal spring. Suppose this is the spring, this is a spring, this is here has a mass. Suppose this is the mean position, this is mean position. Okay, this is mean position. If you want to extend the spring, then we need force. If we apply the force this direction, this is the external force, then the spring will be extended. If we increase this amount of force, the displacements also increase. Suppose if we want to increase this spring, this, and if we want to spring this. Okay, for extend this situation, we need a small amount of force. If we increase furthermore, then we need more force here. My dear student, I think that all of you clearly understand. Okay, now we try to understand what is actually happening here. As this is the mean position, if the body of mass that is hang on the spring is moved downward or upward, when this body go downward, then the direction of the displacement also downward. Okay, if this body go upward direction, then displacement count from here upward direction. Okay, this is our basic concept. Always we measure displacement from the mean position. If this body goes downward direction, the displacement direction will be downward, and if this body go from upward direction from this mean position, if this body go upward direction from the mean position, then the direction of displacement will be upward direction. Okay, this is our basic notation. We know when we apply F amount of force, then displacement occur here. Okay, how much displacement occur here? Suppose x. If we apply a small amount of force, the displacement will be small, and if we apply large amount of force, the displacement will be large. So here has a good relation between applied force and displacement. Work done by variable force in case of spring, in case of spring, by external force, Okay, we just today measure work by external force. We know the force, external force is, this is the external force, external force. My dear student, we know relation between the external force and displacement is a proportional. Why? The relation between the external force and displacement is a proportional, because this is the direction of the applied force and this is the direction of the displacement. If we apply very small amount of force, then the displacement will be very small, and if we apply the large amount of the force or increase the magnitude of the force, then the displacement will be increased. So we can write this. After removing the proportional sign, we can add here a constant. This is the spring constant. My dear student, if we occur displacement very small, suppose the displacement is very small. How much displacement here? Suppose the displacement is dx. Very small amount of displacement. We know the equation, force is F and displacement is very small. We know our previous section. Then after integrating, then we get total work. Suppose this is because of this very small amount of displacement, the force is needed F. So we can write this this equation by this way. Suppose we just try to give you because of this very small amount of displacement, the work done will be very small. So we can write dw, very small amount of work, Because of this a small amount of force or work. Why the work will be small? Because we take the displacement very small. Because of this very small amount of displacement, the work done will be very small. Because of this very small amount of displacement, the force is needed F. This force look like a constant force. So we write here F into dx. Okay, now we put the value of F. F means kx. Now my dear student, as this equation give us the information to work done to measure the work done for very small amount of the displacement. For the very small amount of this displacement, this equation will be valid. But if we want to measure the work done for the very large amount of the displacement, then we integrate both the side. Suppose we integrate both the side. After integrating both the side, we use the limit, then we get the total work. Suppose when the body is here, the displacement is 0 and work done also 0. When the body comes here from point A to B, when this body comes here, the displacement will be x and work done will be total W. Okay, now we put the value. When the displacement is 0, work done will be 0. So the after we see here, after D here has a x, so x is a variable. So we put the value of x lower limit first here, and to work done here as after D here has a W, and then we put the value of higher limit x and W. Okay, we know integration dw is W 0 to W. We integrate with respect to x, so k is a constant come out from the integration part. We know this integration, the power is x is 1, so add 1 2 and divide 2. I think that all of you know the basic rules of the integration. Okay, this is really very simple integration. So we put the value of upper limit minus, use minus, and we put the lower limit. Okay, 2 is a constant come out from the integration part by this way. So we put here upper limit, x replaced by upper limit, x square minus 0 square. So finally we get the equation W is equal to half k x square. My dear student, actually this equation give us the message to measure the work in case of the variable force. If the force is a variable, then we can measure the work with this equation. W is equal to half k x square, not this equation. F is equal to, work done, W is equal to F S. This equation cannot valid for the spring. Suppose we use the force F and displacement is x, so we cannot write F x, okay, because this equation only for valid for the constant force. And here we can see in case of the extent of the spring, we apply the force and displacement also change here, and so force also change here. If you want to very large amount of displacement, then we need to apply the very large amount of the force. If we want to very small amount of this displacement, then very small amount of force is needed. And because of the very large amount of the displacement, we need very large amount of force. Because of that reason, in case of the extent of the spring, here work done to occur. So in case of this find out this work done, we use this equation W is equal to half k x square, not use this equation. Why we cannot use this equation? Because this equation only valid for the constant force and this equation only valid for the variable force. My dear student, I think that all of you clearly understand, and if you face any kind of the problems in any kind of the section, please write down to your comment on the comment section. I am trying to give you the explanation and try to repeat this part again. Okay, thanks to all for watching my lecture. Thanks to all. If you understand to my lecture and if you like my lecture, then please write down your comment and like, share more and more. Thanks to all.